Children, next step is regarding extraction of crude metal is reduction of the metal oxide to metal. Reduction of the metal oxide to metal. The metal oxide can be reduced to metal by using a suitable reagent, reducing agent, and with a flux. Reduction means oxygen is removed. The best method employed for this one is smelting. Smelting, that is by removing, yes, it is melting. We are going to melt the metal oxide to form a metal. So reduction process taken place. Reduction means oxygen is removed. So for that, for the smelting process, we are taking the concentrated ore with the flux. Flux is a chemical, it is cleansing agent. It removes the gangue, or also it makes the metal porous, that is making spongy, plus a reducing agent. Suitable reducing agent like carbon, carbon monoxide, hydrogen, aluminium, reactive metals such as sodium, magnesium, etc. taken. The selection of the reducing agent depends on the nature of the metal. So the concentrated ore, flux, reducing agent. For example, if you are going to apply for that smelting of iron ore, smelting of iron ore, the concentrated ore, iron oxide with the flux, limestone, and reducing agent coke taken in a smelting furnace. What is the activity of the flux? Flux, that is limestone, which is basic in nature, reacts with the silica, that is the gangue, or gangue, which is acidic in nature. Both are in solid state, forming calcium silicate slag. This is also in solid state. This CaO is got from calcium carbonate. On heating, we are getting calcium oxide plus carbon dioxide. This is used as a flux. This is the activity of the flux. Then regarding reducing agent, coke is used. So the coke combines with O2, oxygen, forming CO, carbon monoxide. This carbon monoxide is used as a reducing agent for reducing iron oxide, that is hematite, Fe2O3 with the reducing agent CO. This is in solid state, this is in gaseous state, forming Fe, the metal, which is in solid state, and oxygen is expelled out. Oxygen, carbon dioxide is expelled out, CO2, Fe plus CO2. This is expelled out. Usually furnace, blast furnace like this, it is taken. Slag is taken out like this, metal is taken here. Now in the extraction of copper, This is how for iron ore the steps followed. Oxide of iron now reduced by carbon monoxide to iron. Now with the extraction of copper from copper pyrites formula CuFeS2. The concentrated ore heated in a reverberatory furnace. That is, the concentrated ore first crushed and treated with the flux. Flux is acidic in nature here. So here two metals present, copper and iron. So now it is heated in a reverberatory furnace. Like this, the furnace, here it is heated. So excess of heat applied, then here the metal gets melted. So copper pyrites on heating, we are getting both metal copper sulfide and iron sulfide. Sulfur dioxide is expelled out. We need only copper only we are extracting, so we need this only, but this should be removed first. So this thing should be removed. So this FeS, which is in liquid state, combining with oxygen, that is gaseous state, forming FeO, which is in liquid state, and sulfur dioxide gas is expelled out. On balancing, 3O2, 2FeO, 2SO2. And this FeO with the silica SiO2 forming FeSiO3. This is the slag, solid. This is the flux. This is the gangue, forming a slag. Now this slag floats at the top of the furnace. Then it is removed. Easily it can be removed, which floats. Ferrosilicate, it floats here and it can be easily removed. Now the remaining copper sulfide, Cu2S, and the unreacted FeS. Now this is called as MATI. Now this is, which is present here, now transferred to a Bessemer converter. Bessemer converter is like a X-shaped converter like this. It is transferred to the Bessemer converter. The MATI is transferred to the Bessemer converter. Now this FeS, first we can remove. This FeS and Cu2S present here. This FeS once more combining with oxygen forming FeO plus sulfur dioxide gas is expelled out. Now this FeO once more with the silica SiO2 forming FeSiO3. Ferrosilicate. This is removed as a slag. Now this cuprous sulfide C2S with the oxygen forming cuprous oxide Cu2O plus SO2 gas is expelled out. On balancing, 2 Cu2S, here 3O2, here 2 C2O, sulfur 2 means here 2 SO2. Now this Cu2O, copper oxide, with the remaining unreacted copper sulfide forming copper metal, which is in liquid state, plus sulfur dioxide is expelled out, which is got in molten state. This copper is got in molten state This is solidified, so it has in the surface, since the evolution of sulfur dioxide gas, it has blistered appearance. Blistered means like koppalam pola irukum, like that blistered appearance. So it is also called as blistered copper. On balancing, 6Cu, 2 2 are 4, 6. So 6Cu. This is called as blistered copper. So if it is asked what is meant by blistered copper, means the metallic copper is solidified and it has blistered appearance after the evolution of sulfur dioxide gas. So this copper is called as blistered copper. So very important questions only. Smelting. This is in the case of iron ore. This is in the case of copper. Copper extracted from copper pyrite. This is iron extracted from iron oxide. It's given clearly in book page number 8.